Today, let me explain why colonizing Titan might be better than colonizing Mars. So far, most researchers believe that the Moon or Mars are ideal targets for the first step in colonizing the solar system. These destinations have a dual advantage. They are close enough to Earth, and their surface environments are not entirely independent of current focuses. Among other possible destinations, Mercury is too close to the Sun, with extreme temperatures and other seemingly insurmountable physical conditions. Venus is closer to us, but its atmosphere is toxic, and due to an uncontrolled greenhouse effect, it has become scorching hot. However, although the Moon and Mars seem like relatively reasonable destinations, they also have fundamental problems. Neither of these planets has a magnetic field or enough of an atmosphere to protect future colonists, forcing them to live in underground shelters to protect themselves from deadly cosmic radiation. Who would want to go to a whole new world, only to spend their lives in underground tunnels? In fact, this problem has yet to be solved. So much so that many scientists have recently proposed trying to establish the first human colony, not on the Moon, nor on the Red Planet, but on Titan, Saturn's largest moon. This hypothesis sounds somewhat unexpected, because the surface temperature of Titan is around -180 degrees Celsius. Methane and ethane flow into hydrocarbon seas. However, scientists believe that, in the long term, it is the only place where people can establish a self-sustaining colony. Are they right? Titan is one of the most mysterious moons in the solar system, the second largest moon after Ganymede. With its thick atmosphere and unique geological features, this moon of Saturn has increasingly attracted the attention of astronomers over the years. Unlike any other moon, Titan has a climate model very similar to Earth's, with unique seasons and weather patterns that can offer sunny days, cloudy weather, windy conditions, or rain on that distant world. Its surface has dunes, river deltas, lakes, and seas. Keep in mind that we are still talking about an alien environment, with an average temperature of around -180 degrees Celsius. Let's explore all the positive aspects for future potential colonists. Titan's atmosphere protects its surface from cosmic radiation. Without a dense enough atmosphere to provide protection, especially against cosmic radiation, any colony would be better located underground. However, apart from Venus, Titan possesses, so far, the densest atmosphere of any rocky body in the solar system. This would allow radiation to be reduced to a negligible level. A planet's atmosphere is particularly effective at blocking the most deadly radiation. The potential carcinogenic effects of this radiation have long been known, but the radiation can ionize the atoms it passes through, penetrating almost unimpeded through typical spacecraft or the body of an astronaut. It can damage brain tissue and lead to cognitive impairment. On Earth, besides the magnetic field, we are also protected by the water in our atmosphere. But on Mars and the Moon, there is almost no atmosphere, and you would need 2 meters of water to block half of the incoming radiation, or 4 meters of soil to protect against radiation. Titan's atmosphere is more than 50% thicker than Earth's. Not to mention, the massive magnetic field of Saturn also provides shelter. On Titan's surface, you wouldn't need a pressurized suit. Most rocky planets and all other moons in the solar system lack an atmosphere. Even Mars' atmosphere is barely denser than a vacuum. However, Titan's dense atmosphere also means that the air pressure is more comfortable for human visitors. It's only about 50% higher than Earth's, which is fully manageable. This means colonists could move on the surface without uncomfortable pressurized suits. The thick atmosphere allows for greater thermal exchange with the environment, so heated, super-insulated protective gear is needed. And, of course, oxygen respirators. These needs. Our current technology can already meet these needs. Titan has the richest nitrogen reserves in the solar system. Thus, colonists would only need to add oxygen, using the existing nitrogen as a buffer to create breathable air. In fact, Titan's atmosphere is already composed of more than 98% nitrogen, whereas ours consists of 78%. This makes it more similar to Earth's atmosphere than any other atmosphere in the solar system. Although Titan lacks oxygen, there is water beneath its surface, in the form of ice deposits. From there, oxygen can be easily extracted. For breathing and burning hydrocarbons, colonists would need to live in air-controlled sealed structures. Additionally, advanced spacesuits are crucial for outdoor missions. Generating oxygen through water electrolysis or genetically modified plants could help create a breathable environment. Titan is the only known celestial body in the solar system, other than Earth, with large amounts of surface liquids. It displays a variety of terrains, much like our own world. However, these liquids are not water. They are methane and ethane. They remain liquid at temperatures as low as -179.5 degrees Celsius. Titan has abundant solid and liquid hydrocarbons on its surface, providing all the fuel needed for a colony. In fact, it contains hundreds of times more natural gas than all the Earth's reserves combined. Fortunately, in Titan's oxygen-free atmosphere, these liquids are not even flammable. This makes them easier to convert into fuel. Although invisible, water is abundant here, at temperatures twice as cold as Earth's coldest temperatures. Water on Titan's surface remains permanently frozen and as hard as granite. While Titan lacks oceans like those on Earth, its surface still holds large amounts of frozen water, locked beneath the rocky crust. Scientists believe Titan's outer shell is mostly composed of ice. Extracting ice should not be too difficult. Titan's oceans could provide polymers for construction. Titan has almost limitless liquid and solid hydrocarbon supplies, along with everything colonists would need to build permanent shelters. This orange world doesn't rely on wood, bricks, or metal, as we do on Earth, but instead uses space-age polymer components for building ideal surface structures. Thanks to the thick atmosphere and Saturn's magnetic field, the surface is protected from harmful radiation. Colonists will be able to construct surface habitats without needing to carve out massive underground shelters to avoid surface dangers. One of the main challenges is energy. Considering Titan's distance from the Sun and its thick atmosphere, solar panels would be highly inefficient. Titan's atmosphere is about 10 times denser than Earth's. This means the brightness of Titan's sky would be similar to Earth's at twilight. One possible solution could be the use of advanced nuclear reactors or harness methane and ethane lakes to generate power. Additionally, alternative energy sources like geothermal could be considered. Titan's atmosphere contains a large amount of nitrogen, which we can use as fertilizer, just as we do on Earth. Although Titan itself is not habitable, it seems to contain everything needed to establish a fully self-sustaining colony. Considering its 1.2 billion kilometer distance from Earth, this will be crucial. Food production will be a serious challenge. Colonists will need to develop greenhouse systems that can operate in Titan's frigid temperatures, using methane as a carbon source for plants. Additionally, cultivating resilient microorganisms that can convert local resources into food will be crucial for ensuring a sustainable food supply. Fortunately, Titan offers all the waste products colonists need to grow food. Its nitrogen-rich atmosphere, along with abundant methane and ammonia, can be used to cultivate crops and establish a self-sustaining ecosystem. Now, let's take a look at the resources near Titan. The Saturn system has 62 moons and multiple rings made up of billions of ice particles, even though Titan is by far Saturn's largest moon. Other bodies in the Saturn system are also rich in resources, economic and exploration potential. For example, nearby Enceladus has an underground ocean, kept liquid by tidal friction from Saturn's immense gravity, making it one of the most likely places to find extraterrestrial life in the solar system. A permanent base on Titan would be perfect as an exploration outpost, a launch platform to many other destinations beyond the solar system. We could even fly there. So far, the easiest and most economical way to explore Titan is simply to strap on a pair of wings. Because of its small size and low density, Titan's surface gravity is only about 14% of Earth's, much less than the Moon's. The high ratio of atmospheric density to surface gravity means that airplanes would require far less power to stay aloft. In fact, humans could fly using wingsuits made from materials we can easily produce with today's technology, without worrying about falling from great heights. Here, free fall acceleration is 7 times lower than on Earth, and terminal velocity is 10 times lower than on Earth. So, if you fall from any height, your impact speed wouldn't exceed 18 kilometers per hour. All of this is fascinating and exciting, but of course, it doesn't mean that Musk or NASA will shift their focus from colonizing Mars. Unfortunately, Titan is a distant world, and reaching it requires a tremendous investment of time and resources. Significant advancements in aerospace technology can get us there, but within 20 years, we only need to plant our flag on the summit of Mars, the red planet, to achieve extraterrestrial colonization. When it comes to colonizing Titan, we must realize this is not just a short visit. Like our plans for Mars, it would mean building a spacecraft designed to carry a large number of humans and resources necessary for survival on Titan. That spacecraft must be self-sufficient during the long journey, capable of sustaining human life for months or even years. The crew must be carefully selected and trained to face the unique challenges of living on Titan. Astronauts would need to be multidisciplinary, with knowledge of engineering, medicine, and other fields. Before sending humans, it would be wise to send advanced robotic missions to lay the groundwork. These robots should handle tasks like building shelters, gathering resources, and preparing the environment for the arrival of human crews. Once on Titan, the astronauts would need to land safely and begin establishing the colony. This phase would involve building habitats, producing food, and implementing life support systems capable of functioning under Titan's unique conditions. All of this would require immense funding, and only if we find a way to. When chemical rockets become more efficient propulsion technology, all of this will be achievable. It won't happen in 20 or even 100 years. Most likely, after we draw conclusions from colonizing Mars, it will take centuries before we seriously consider colonizing Titan.